Woohoo! Figured I'd try some intro music. And what can be better than fiddle music? Eventually I'll learn how to actually splice the music in and not just like have my Mac record music that's playing out of my Mac, which tends to sound terrible. Let's talk about composition of classes. So we're going to build a grade report, and then we'll build a yearly grade report that uses that grade report. We'll do a couple of other things. We'll look at a quick example using a class from a main method. We've seen how to do this before, but we'll see it again. Composition of classes, so we'll make a class, we'll make a second class, and the second class will use the first class. I want to show a little bit about the Java visualizer, and some notes on your default methods, so your constructors and your toString methods. I tend to call these the Miranda rights methods for a reason I'll explain when we get there. So we had our calorie counter. Very simple class, it just stores the number of calories. You can imagine this as like a really simple app on your phone. Every time you eat something, you say, add calories. I had 700,000 calories of Reese's Peanut Butter Cups on Halloween. I don't literally have 700,000, but I have a lot of calories on Halloween. We've got a constructor, sets the count to 0. We got a reset method, so on and so forth. Now, we know we can write another class that uses this. We could write a calorie test class with a main method. We'd create the calorie counter. We could, print out the number of calories, call some methods, so on and so forth. That would be pretty good. And so note, we're creating a new instance here. We're invoking the constructor. That's going to create a new instance, and we know what that constructor is going to do. It's going to set the initial calories to 0 because we just saw the code for that. Now, we know the BlueJ workbench will let you do these steps visually. If you go ahead and create these two classes in BlueJ, you'll see calorie test here, and then you'll see this little dotted arrow letting you know, hey, calorie test is using calorie counter to do some of its work. So composition of classes, this is a little bit different. It's not when one class uses the other class, it's when one class is made out of the other class. So first we're going to make a class to represent a grade report for one term. Then we're going to make a class that represents grade reports for an entire year for 3 terms. Now I should note I'm making a bunch of simplifying assumptions here. I'm assuming it's exactly 3 courses, there's no half-credit courses, so you can't do 2.5 or 3.5, you can't do an overload, you can't drop a course, that's going to be exactly 3 courses, and they're equally weighted. And I'm assuming that there's a whole year, I'm assuming you don't study abroad, there's no transfers, it's just 3 courses, and then 3 terms per year, fall, winter, and spring, which is essentially how we have it at Knox. So these are simplifying assumptions. You wouldn't really build a system this way, it would be too brittle, it wouldn't be flexible enough. But this lets us demonstrate a couple of interesting things about composition of classes. So what should the grade report for one term be? What state and behavior do we need to have? Think about that for a moment. Well, the simplest way to do this, the state would need the grade for all 3 courses. And for simplicity, let's just assume these are doubles between 0.0 and 4.0. So 4.0 is an A, and 0.0 is an F. And then the behavior, well, we're just going to compute the total GPA. We'll just average those 3 values together. Well, here's what we could do to do this. We got our grade report class. We've got our 3 doubles, G1, G2, and G3 for the grades in the 3 different courses. We've got a constructor. We're not doing anything in the body of the constructor. We'll talk about that in a second. And we're passing in these grades as parameters to a second constructor, and then setting them to the instance variables. So we've got this constructor doesn't have a body, this constructor does have a body, which takes these 3 parameters and sets them. And we've got this compute GPA method where we're just going to add up the 3 grades and divide it by 3. So a pretty simple class for representing grades for 3 courses for one term. Now, I should note, holy crap, we have 2 constructors. This is often called overloading. When you have 2 methods with the same name, but different lists of parameters, we call this overloading. There's also overriding, which has to do with inherited methods, which you don't really see in 141. You'll see that in the future as you do additional Java programming, especially starting in the second course. So this is perfectly legal to have 2 methods with the same name but different lists of parameters, and how you know which one you mean is by what parameters you give it. If you don't give it any parameters, you want this one. If you give it 3 doubles, you want that one. If you give it some other combination of parameters, it's not going to compile because there's only the 2 possible constructors. So this constructor here pop on over to Moodle and try this out. What value will this grade report constructor set our 3 instance variables? So I'll give you a chance to try that out on Moodle. Did you come up with 0.0? If so, you're correct. Now, we know that with your default constructor, if you don't define any constructors at all, and Java makes one for you, we know it sets everything, all the instance variables, to their default value. So 0 for int, 0.0 for doubles, null for all reference types, and so on. Well, what you don't know is that even if you make a constructor and explicitly don't initialize things, Java is still going to initialize them to their default value. This is actually a security mechanism back in the olden days of C and C++ programming. If you created a new instance or a new array or a new something, you didn't actually have any guarantee that the initial value of an int would be 0. You could have a bunch of instance variables in a C++ class, and they would just have whatever happened to be in the memory there. Often the operating system would zero out the memory, but sometimes it wouldn't. So people would create these gigantic arrays of characters and just munge through looking for anything that looked like it might be a password from a previous program where somebody had to type in a password or something like that. There are many other types of security vulnerabilities. This is actually a security issue. Even if in your constructor you explicitly don't initialize your instance variables, Java will still make sure that they get initialized to 0. It'll do it for you, even if you don't do it. So here's another question. I'll give you a chance to head over to Moodle and try this out. Can we drop the this keyword here? So for the second constructor here, where we have this.g1 equals c1, what if we got rid of this and just said g1 equals c1, g2 equals c2? Would that still work? Head on over to Moodle, try this out. Did you come up with yes? If so, you're correct. This would be fine. We could leave the this is out. It's unambiguous. When you say g1 here, in this method, there's nothing named g1, so the only g1 it could possibly refer to is the instance variable. All these parameters are named c1, c2, and c3, so there's no ambiguity. Now, what if we wrote it like this? Can we name these parameters g1, g2, and g3, same as the instance variables, if we wrote it this way? I'll give you a chance to try this out on Moodle. Did you come up with yes? If so, you're correct. If you say this.g1, that unambiguously means the instance variable, whereas when you say g1, that means, unambiguously in this example, the parameter, because those are the only things named g1. We have g1, we have this.g1. So this would be okay. How about if we write it this way? So here, we have the instance variables, g1, g2, and g3. We have these parameters, g1, g2, and g3. Can we write it like this? Is this legal? Go on over to Moodle and try this out. Did you come up with no? If so, you're correct. This is ambiguous. When you say g1 equal g1, Java's going to look at this and say, well, you're not saying this.g1, you're saying g1. So I'm going to look at the closest g1 I have, which happens to be the parameter. So it's going to take the parameter, whatever you passed in for that parameter, and reassign it to itself, which has basically no effect. This will never touch these variables up here. So this is not going to work, so you can't write it this way. So that's a grade report for one term. What about a yearly grade report for all 3 terms? What would that look like? What state and behavior would that need to have? Think about that for a moment. Well, here's a really, really simple version. We'd need grade reports for each of the 3 terms, fall, winter, and spring. We might also need the student's name. And then what behavior might we want to have? I don't know, maybe compute the yearly GPA, maybe compute the GPA from each term. I don't know. We could do other things as well, but this is a pretty good start. So here's what this would look like. Yearly grade report. So we want to have the student's name, and then we want to have grade reports for fall, winter, and spring. What does our constructor look like? Well, maybe we have this yearly grade report constructor that takes a student's name and their grade reports for fall, winter, and spring. And then we just assign those in here to the instance variables. Now to compute our yearly GPA, since we know that each term has exactly 3 courses, and there's exactly 3 terms, to compute the yearly GPA, we can actually just sum up the average GPA from fall, winter, and spring from the 3 terms, and then divide the whole thing by 3. Now, we can only do this because we know that these terms happen to have 3 courses, so computing the average of 9 different things is the same as computing the average of them 3 at a time and then averaging the averages. Normally you can't average averages, but here we can because we know that the same number of things went into the averages. It's kind of a hack. And if we change grade report so that you can have 4 credits or 2.5 credits or something like that, then this function won't work anymore. This method won't work. But for now, I don't know. It's a pretty simple thing. We'll just go ahead and do it this way. Now, interestingly, one of our other behaviors, for a yearly grade report, you might want to say, hey, what's the GPA for the fall? Well, here's another example of delegation. We can say, well, compute fall GPA. Well, how does a yearly grade report compute the GPA for just the fall? Well, it says, hey, fall grade report, just tell me your GPA, and then we'll go ahead and return that. And we could have another one for winter and spring. They would look basically the same. So again, composition. We're building a yearly grade report out of the grade report class we just wrote. So the instance variables are of a type that we ourselves wrote. And again, delegation. We're delegating to the compute GPA method in fall, winter, and spring. And again, down here. So a question is, what does this actually look like inside the computer? So normally, if we're doing this in class, I'd write it on the board. Since we're doing this as a video, I'm going to try the Java visualizer. This is Dave Pritchard's Java visualizer, which is based on Philip Guo's Python visualizer. So I've gone ahead and plugged all that code in. Whoops. Oh my gosh. Look at that. Well, hold on. Let's scroll the rest of the way up. There we go. I've gone ahead and plugged that code in. I've basically put the 2 classes in here, and I think this is necessary that you have to make one of them not public. Only one of them can be public. I'm not really sure. But anyway, I plugged both of the classes in here, and I stuck in a really simple main method that just creates a grade report for fall, for winter, for spring, and then creates a new instance of the yearly grade report for student Charlie Brown, and then computes the yearly GPA. And what we can actually do is step through this. So watch this. I'm stepping through this first constructor, and when this returns, bam, look at that. There's the fall, which grade report has G1, G2, and G3. Those are the instance variables. Let's do this again. Boom, 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 boom. Shazam. There's winter. Boom, 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 boom. There's spring. So we have grade reports fall, winter, and spring. Those are what the variables are named in main. Let's go ahead and walk through the yearly grade report constructor. So this sets name, sets fall, sets winter, sets spring. Boom, boom, we're done. So main, oh wait, and one more. There we go. Main now has fall, winter, and spring. Fall, winter, and spring point to these grade reports, but we also have a yearly grade report, which has the name, Charlie Brown, and then references for fall, winter, and spring. So at this point, there's aliases. We know this is fall, winter, and spring for main, but they're also known as fall, winter, and spring with different references from inside this yearly grade report. This is really, really, really cool. This is what the Java visualizer allows you to do. It allows you to draw these box and arrows diagrams that you can look at and kind of get a sense of what's going on inside the computer. I mean, again, it's not literally what's happening inside the computer. It's not like little arrows inside your computer. They're all references, which really just mean addresses or memory locations. Memory is essentially just a gigantic array. If you take CS201, you'll learn more about this. Anyway, so this is kind of what this would look like. And interestingly, this says I have 39 of 62 more steps. How many more steps? Oh, I guess we can also go in here and compute the GPA. Oh, and this is showing the entire delegation process. Oh my gosh, this is fantastic. Look at this. We're calling compute yearly GPA, and then we're slowly building up this sum, and it's actually walking through each of the methods and showing you how it's producing this total. Oh my gosh, this is fantastic. Look at that. Look, it even tells you what the return value was. It tells you, and since it's not like a variable or anything, it's just a return, it actually tells you the return value. Oh my god, that's amazing. Look at this. Now we know what sum is. Now and it tells you what that return value is. Oh my gosh, this is fantastic. And then it actually prints it. Oh my gosh, I love this. This is so cool. Holy coolness. Oh, that's fantastic. Wow, so that's the Java visualizer. That's what the whole picture would look like from running this code. Let's talk again about these default methods. So I always call these Miranda rights constructors. If you watch any cop show, at least in the US, whenever you arrest somebody, read them their Miranda rights. You have the right to remain silent. Anything you say can and will be used against you in the court of law. That's not that interesting. You have the right to an attorney. If you cannot afford an attorney, one will be appointed you by the court. So I call the default constructor and the default toString, the Miranda rights, because you have the right to a constructor and the right to a toString method, but if you can't afford one or choose not to provide one, Java's going to provide one for you. You have to have a constructor and a toString method, even if you don't want to write it yourself. The problem is the default constructor and the default toString method, they're the simplest thing that Java can possibly provide for you. It's not in the business of getting you like amazing toString and constructor representation. So, if you want a really good constructor, really good toString method, you kind of got to write it yourself. So here's a question. Here's our bottle class. We got a capacity for the bottle, so we're just representing like a simple water bottle with the capacity, number of ounces of liquid in there or whatever. Here's a main method, creating a new bottle. Does this compile? We're not defining a constructor. Try it out on Moodle. What do you think? Did you come up with yes? If so, you're correct. This does compile. We didn't provide a constructor. Java provides a constructor for us and sets all of the instance variables to their default value. So this method call here totally works. Here's the next question. What does this print? So we've got our print statement here, b.capacity. We use the default constructor. What's that going to be? Try it out in Moodle. Did you come up with 0? If so, you are correct. This makes sense, right? We're using the default constructor because we're not providing our own. The default constructor is going to set all the instance variables to their default value. The default value of an int is 0. How about this? So a slightly different version. This is just a simple person class with an instance variable for the name. Now, we didn't provide our own constructor, so what's this going to print? What's the default constructor going to do? Try it out in Moodle. Did you come up with no? If so, you're correct. String name is an instance variable, but it's an instance variable of reference type, not primitive type. The default values of all reference types is null. So when you do p.name here, using this default constructor, p.name is going to be null, so it's literally going to print out null. Let's visualize this. I'm going to try this Java visualizer again. So I plug this in. We're running it. Here we go. We created person. Person is null. So we got p, which points to our instance of person. Name is null. Now when we go ahead and print it out, we actually can see that, in fact, we do get null. So toString methods, all classes have a toString method. Now if you don't write a toString method, you get a default one, but it's not very good. So let's see what toString of the person class looks like. I got the Java visualizer queued up for this as well. You could check this in BlueJ as well. Oh, that's weird. That's not what I wanted. Let's start closing these because I think they're causing me confusion. Let's try this again. Java visualizer, processing the code. Ha! Well, that's interesting. Well, that's what it does. I thought we were going to get... Here, let's jump back to the beginning. This is cool because it lets you go kind of like line by line. So here we've got p as our instance. We're going to go ahead and print it, and you can see what it's printing. It's printing the name of the class, and then an @ sign, and then some, what is that, an 8-digit hexadecimal value or something. I'm pretty sure this is the hash code. It may actually be based on the memory address. The JVM ensures that each of these is unique for each unique instance. But it doesn't really do us a whole lot of good to have this here. Like, what does this mean? This doesn't... I can't look at this and know that that means this. I mean, they're not really related to each other because it's the default toString method. It's not a particularly good toString method. So what we want to do is actually provide something that looks more like this, our own toString method where we return, like name is the person's name or something like that, return a reasonable looking string. Then if we run that, we can go ahead and see what it looks like. I'm actually just going to go ahead and hit edit code here, and I'll go ahead and punch this in, public string toString, return name plus and I'll leave a space, is the person's name. How about that? Now we'll visualize the execution, and if we run this, hit last to run to the end, you can see null is the person's name, which makes sense because we never actually set the person's name because we're still using the default constructor, so it's just sticking in null literally. I should note, toString is automatically invoked whenever you concatenate an instance with a string, whenever you print an instance, whenever you directly invoke the toString method. So if we look at this example, we're printing out P as if it were a string, so printing something automatically invokes the toString on it if you haven't already. Other ways to get toString to happen, if we did something like P, is the, toString method or something like that, this is also going to force it to call the toString method, because anytime you take an instance of any class in Java and do a string concatenation with a string, well, that means, hey, I got to get this instance into a format that I can concatenate with a string. It's going to automatically call the toString method. And so this gives you tremendous flexibility. Any class you write, you can write your own toString method and define exactly how that class should be printed. This is very useful for debugging. It's very useful for input-output. It's useful in a number. It's useful, believe it or not, with using the actual debugger in either BlueJ, or eventually when you get to learn Eclipse or JBuilder or NetBeans or one of these more powerful IDEs. The debugger actually calls the toString method all the time, so if you don't have one, it's not nearly as useful. So there's a lot of reasons to take seriously the need to go ahead and build a toString method. Great, that's all I had. Wow, that was pretty efficient.